Hi, and welcome to Redefining Application Delivery. What do we mean when we say application delivery? It's everything you need to do to build, deploy, and maintain an application. Whether you have a simple COTS app, like an agent that needs to be installed on a server, or you've got a complex application broken into hundreds of microservices, an app needs to be built, packaged, deployed, and updated. And it's not enough just to have a process. You need to hit your outcomes, whether that's to minimize downtime, release new features regularly, or patch vulnerabilities quickly. Hi, I'm Robin Beck. I'm a developer advocate here at Chef. And today we're going to talk about how Chef for application delivery can help you meet those outcomes. Our agenda for the session will cover an overview of Habitat, including some of the latest and greatest features. And then we'll hear from Scott Lavin at Panera Bread and some of the exciting things they're doing with the product. We'll wrap up with Matt Rock, a senior engineer on the Habitat product, who will take us through a demo of how it works with a real application cluster. To get us started, though, I'd like to introduce Mike Krasno, Senior Product Manager for Habitat. Hey, Mike, how you doing? We got you on the line?
Hey, Robin. Yeah, I'm doing okay. How are you?
I'm hanging in there, thanks. You hanging in there through this storm and weathering it all right?
Yeah, something about doing this from my office/daughter's bedroom is just not the same as being live at ChefConf, but we'll do our best.
For sure, for sure. Well, your virtual background's holding up just fine.
That's good to hear.
I've been really excited to follow some of the new releases around Habitat, the 1.5 major milestone that came out this year. So I'm excited to hear about all the new features that you've got to show us today. So let's dive in.
Yeah, let's do it. So back in the old days, back when I used to be able to travel to customer sites, I'd go talk to y'all and I'd hear that even though you've automated your infrastructure deployments, you've automated your application deployments, you're still not happy with the outcomes. It still takes too long to get products from development into production. Things that worked on the developer's machine don't always work in production. The pipeline's always breaking. Deployments fail more often than they'd succeed. So why does it take so long to ship an update? Why do so many deployments fail? The root of all these issues is complexity. You've got multiple processes, multiple teams, multiple systems. This is especially a problem in large enterprises where you've got decades of technology. You've got some applications you've built, some that you bought. All these applications are running all over the place. They're in the cloud, they're running out of the edge, they're in your data centers. And now you've got new mandates. You've got to deploy to the cloud or figure out your multi-cloud strategy. You've got to move to containers or deploy to Kubernetes. So the question that everyone's asking is, how do you reduce the complexity? How do you get consistent processes? How do you meet your objective, which is to deploy applications quickly and securely? The key is to think about both ends of the delivery framework, right? Both at the front end of define and build, and then at the end of how you deliver that. So first, you need to define how the application is built, deployed, and maintained. And I want to get back to this in a few minutes, because that definition phase is really critical to getting all this right. Once you've got that definition, though, you can package up into a single artifact the application, its dependencies, the instructions on how to run and deliver that application. You package that all up in a single artifact, and then you can deploy that to a much simplified CI/CD system. You can use your existing CI/CD tools, but in a much more simplified way, because you have a single package and a single process to test and deliver that application. So then, because you've got a single artifact and an agent to consume that artifact, you can deploy your app anywhere, to bare metal, to the cloud, to a container. And then finally, you can send data from that application into a dashboard to be able to validate that you have the right versions deployed in the right places and that the application is healthy. The other key is having the right tool for the job. I know many of y'all are using Chef Infra today to not only configure your infrastructure, but also to deploy your applications. Or maybe you're using another infrastructure management tool. But in either case, what you've seen is that doing complex application deployments with these tools is hard. The tools just aren't designed for actually deploying and managing the applications, especially when we're talking about complex clustered applications like SQL, for example. So when we built Habitat, which is part of the application delivery solution. We started from the application down. This leaves infra to do the job that it's meant to do, which is to configure the operating system. And then Habitat is there to set up the application, the middleware, the packages, and the system libraries. So I want to go back to this idea of application definition. So what do I mean when I say application definition? Well, it's the instructions in code that the application needs in order to be both built and run. So when you have these clear definitions, the application teams have everything they need to build the application, and the infrastructure teams have everything they need to operate and validate the delivery of the application. So it starts with the application itself. Where's the binary, or where is the installer to run that application? How do you build that application if it needs to get built? Once it's running, what do we need to do during runtime to be able to check its health? What happens when it runs? What happens when it's installed? How does it get configured? What dependencies does the application have? So does it depend on other system libraries? And then what are its relationships? How does it talk to other application services? How does it bind to those services and cluster together? So when you have all these application definitions in one place, we call that the manifest. Once you have that application manifest, you know that you can then build a single artifact that contains the application, all of its dependencies, and all the instructions to both build and run that application. A big part of these definitions is the runtime instructions. It's things like, how do you manage the deployment? When you do a release, how do you push that release to the application? Do you do it at once? Do you do a rolling pattern? Then there's questions about sequencing. How do you build up all of the services that the application needs in order to run and connect them to each other? And then once you're running, how do you manage the services? How are they clustered? How are you defining healthy? What actions do you need to do when you reboot, install, or configure? And one of these pieces is what we call the hooks. And you'll see this in the demo in a little bit, that we use these hooks to be able to define how the application, to define actions that happen while the application is running. So once you've done all that hard work, once you've written this manifest, then you've got all your puzzle pieces in one place so that you can actually test and deploy that application. Then, since all of your applications have their own manifest, you can have a consistent pipeline. You can have one way, one process to build and test your applications. The output of that is a single immutable artifact. The application, all of its dependencies, wrapped in one artifact. You can then deploy that out to all your environments and check the status of those deployments to ensure that your applications are deployed and healthy as you intended. So then the release teams that are in charge of this release, they can focus not on, do I have all the right pieces, and do I have all the right build and runtime components? I can focus on validating that the deployment happened, and that focus on when do I promote from dev to staging to production. The results that we see from this are almost too good to be true, right? We see from folks that are using this solution that they go from weeks to deploy a new feature to minutes. They see reduced failure rates. They see a simplified pipeline. They see fewer tools that they need to use. They see fewer manual processes that they need to use. So how does this work? What are all the pieces of the application delivery solution? Well, it starts on your local developer workstation with a tool we call Habitat Studio, which is a clean room environment to be able to build those manifests and test those manifests. Then you take those manifests and the artifacts and push them up to our builder service. And that's a service that can either run as a SaaS service that we provide or on-prem if you choose to install it yourself on-prem. So this builder service connects to your CI/CD tools to manage your artifacts and to push updates to your supervisor. The supervisor is the agent that runs on the servers that manages running and maintaining that application. So it's the thing that takes all those instructions that you've written and actually reads them and executes them. And then finally, that data, the health checks and the status of the supervisor deployments gets reported up into Chef Automate. So you've got visibility and validation to ensure that your applications are getting deployed as you intend. So where does this fit? We see the solutions being deployed across the enterprises in a bunch of different use cases. You'll hear from Scott at Panera in a few minutes how they're using Chef for application delivery to help deliver applications out to the edge to their retail locations. We also see folks using these solutions to help build secure, efficient containers and run those applications in Kubernetes. We've helped folks migrate their old Windows 2008 applications into a modern framework and get them deployed on modern Windows platforms. And we've helped folks with their process of how do we get continuous delivery and alignment with our DevOps teams. But rather than continue to hear me talk about how great I think our products are, I thought it'd be good to bring in someone who's actually using them. So let's bring in Scott Lappin. He's Director of DevOps at Panera Bread. Panera's been doing some cool things to deliver applications both out of the restaurants and in their e-commerce sites. Scott's got a panel later with some of his team to talk about how they're doing this, but I wanted to bring him here to have a short conversation with us now. So Robin, can we get Scott on?
Hey, Scott, welcome.
Hey, Robin, how are you doing?
Doing well, thanks. I like your virtual background there. How are you holding up working from home?
It'd be nice to be out of the store, that's for sure. But we're getting by. We're getting by. Nice to have a haircut before doing a conference sometime.
Yeah. That's great. So Scott, tell us a little bit about what you do at Panera as the Director of DevOps and a little bit about the challenges of your day-to-day when you arrived.
Yeah, so I was brought in about 2.5, 3 years ago now to Panera to try to solve some of the problems that they were facing, right? They were like most companies in their DevOps journey. They had pockets of automation here and there, but didn't really have a cohesive view as to where they were going. I quickly realized that just simple configuration management was an issue. Having used Chef in the past at MasterCard, I brought you guys in to clean that up. We had some really big successes early on with our cafe systems, getting Chef in to be able to manage our server resources in the store. Those successes moved them to get us more into the data center as well. And that's when we kind of hit, what most people do, I think, with Chef is that it's amazing for configuration management, but we started running into the difficulties with that, using it to manage application deployments. And that's when we made the move to Habitat for application deployments.
That's great. So yeah, you brought Chef Infra in order to do some of the configuration management side of things. And you quickly ran into, I think, what a lot of customers do, which is you start using a tool to deploy applications that really isn't designed to fit that bill. And so it's great that you were able to turn to our other product, Habitat. And so how are you using it? Because a tool like this does have a lot of features that you may or may not use depending on what your pipeline looks like and how it's set up.
Yeah, so it's different per team for sure, right? I mean, we try to be flexible. I really like the idea of allowing a team to be able to use a set of tools, but use them the way they want. How our e-commerce team, for example, wants to use it in the data center versus how our cafe systems team want to use it in the stores are slightly different use cases, right? But to the stores themselves, to the cafes, we have cafes that are completely running on their applications under Habitat right now, from the point of sale, kitchen display, back to the compute resources in the stores, as well again as the e-commerce services in our data center. So it's being used across the board at Panera at this point.
So that's quite interesting. You mentioned a couple of fun use cases there, including not just your e-commerce system, but also edge computing and edge devices. So you're using Habitat to manage both of those, it sounds like. How has that affected the way that your teams are working together? Has the process of building your applications and deploying them become a more unified process with more communication and cohesiveness?
For sure, the communication's there. It's hard to break old practices, right? I mean, we still have the developers that want to toss it over the wall on occasion to have somebody else do the deploy. But we're quickly realizing when the deploy is press one button and sit back and do nothing, and 500 stores are updated, and that includes 800 systems across, or 1,000 systems across 500 stores, and you don't do anything but click a button. The development team is really starting to realize that maybe we don't need to pass the buck to somebody else. Maybe we can go ahead and press the button ourselves. And that's really what I'm trying to get them to. And it's really starting to happen, which is great. to get the developers to really understand their systems is the major goal, right?
Absolutely, and I'm sure it frees up a lot of time and energy for them to work on the more creative aspects of their job rather than, managing all of those servers individually.
Yeah, it
So,
does. It absolutely does.
awesome. Awesome. Yeah. So, in addition, so you've talked a little bit about how it kind of helped you scale CI/CD in the sense that you can just, press the deploy button and kind of watch it roll out across all those systems and not have to worry about managing that process manually. Can you talk a little bit about how it has worked across multiple different environments, such as maybe minimizing drift between dev and prod, or the number of versions that need to be maintained?
Yeah, well, I mean, certainly the first thing that it cleaned up was our testing environment. It seemed whenever anywhere I go, it used to be. I have a kind of a standard joke, and I apologize if there's testers out there, but I have a joke that seems like whenever the testing environment is down, like QA testers are falling down elevator shafts or something. They're like, QA's down, I got nothing to do, and they wander off and go do whatever they do, right?
At least
So
we're all working from home right now, right? No elevators to fall through.
right, but so just having it consistently work, I think, makes the world's biggest difference, right? So absolutely, our test environments are now, have a 99.9% uptime, right? If there's something wrong, we know what it is, right? Because we know what we pushed in there, and it's no longer are the application teams just kicking it over to another team saying, hey, what broke in QA? They go, oh, I deployed this and it broke. I know what it is. Let me fix it. It's really empowering the dev team to be able to fix what they want to fix when they see the problem. Beyond that, I mean, if you think about Panera or any other places, and a lot of people don't think of it this way, but we have 2,400 data centers, right? So each one of our cafes has 15 or so devices in there, along with compute. Or along with server infrastructure. So there's Windows infrastructure in there. There's a Linux Red Hat in there. So we've got to manage that, and for the most part across a T1. So being able to know that when I deploy something to a channel, that it may not go the first time, but eventually overnight it will. Like the errors or the failures are in the infrastructure and in the networking, not in Habitat, right? I say, hey, deploy this to a prod group, and then it goes, and I know it will go, even if it has to just keep retrying, versus our old model of a push, check and see if it was there. Maybe it's there, maybe it's not. Check again, push again. It was an all-night process, right? So people were literally up all night pushing things around the stores, and it would take weeks to deploy things. Now we can deploy our entire, to our entire fleet overnight if we want to.
That's great to hear. And, looking at that kind of mixed infrastructure where you have Windows machines alongside other types of host OSs and even virtual machines and other types of devices mixed in with Edge, it's just nice to probably have a unified build process for all those different types of applications rather than having to shepherd each application on its own through its own pipeline.
Yeah, absolutely. So we have a centralized DevOps team, right? And our goal and our job is to really support everybody. And we were able to support all of Panera, honestly, with 3 people. And that's supporting the infrastructure as well, too, right? And that's because if a build fails, it's the same style of build, if you will, across the board, right? And so what Ecom is doing, what iCafe is doing, what our other systems are doing, it's the same. So when there is an issue, we know how to handle it because they're all building the same way and deploying the same way.
Well, this type of story is certainly what inspires me to do my job over here at Chef, and I so appreciate to see you having success with all of our products and utilizing them in really creative and fascinating ways. So thank you so much for your time, Scott, and we'll really enjoy checking in with you as you go through this process and expand and hopefully get all your cafes back online and up and running at full capacity pretty soon.
Absolutely. Thanks, Robin. I really appreciate it.
Yeah, take care. Well, Scott had a lot of great things to say about the benefits of using Habitat, but I definitely want to see it in action on a real application. So to give us an idea of how all this works in practice, I'd like to talk with Matt Rock, one of our principal software development engineers. What's new, Matt?
Hey, Robin, how's it going? Yeah, so, I was at a customer site, about a year or so ago, and they were looking at using Habitat to automate SQL Server. And in particular, they were looking at Habitat to automate SQL Server high availability. So apparently, it was taking them, literally days to set up SQL Server availability groups, get all that stuff wired up together. And interestingly, after visiting with them, I went off to do it myself, and it's no joke. It's there's a lot of moving parts involved in that. And then more recently, I was at another customer, and they were asking us specifically, well, how do you update SQL Server? One of the main reasons why people use SQL Server in a highly available mode is so that they can update it without having any downtime. So what I'd like to kind of dive into is how we can use Habitat to automate that whole process.
It'd be great to have you walk us through, at least at a high level, what this process looks like.
Basically, what I have right now, I've already stood this up, and I've used Habitat to do this. So in Automate, I can see my SQL Server service group right here. I see over on the right hand, I've got two SQL servers. I've got SQL 1 and SQL 0. It is a highly complex thing to set up and configure, because really there's so many different aspects of it. For example, you've got Windows Active Directory. That plays a key role. Another big part of the equation is Windows failover clustering. And then within SQL Server alone, you've got all sorts of things like availability groups, listeners. You've got to make sure that you closely coordinate when you add a database to your availability group, that you take a full backup, you recover it onto your secondary replicas, that all that stuff happens in just the right order to make everything work. So there's quite a bit.
It sounds like a bit of an administrative nightmare to start with. So automating it would be really useful. So walk us through what we're seeing here in the dashboard first.
Yeah. So what we're seeing is so I've got two nodes of SQL Server. So in this case, I've got a pair. I've got a primary and I've got a secondary. I'm currently on, this is the version of SQL Server that I'm running. So those that are familiar with SQL Server may know version 14, so that's SQL Server 2017. And my build number here, 1000, that is basically the RTM level of SQL Server. So this is what you get right out of the box with SQL Server. Over here on the right, some key bit of information here is I am running an update strategy of at once. And I'm listening to a channel called SQL Update. So what that means is that my supervisors are configured to update themselves as soon as they see a new package, a new Habitat package inside of the SQL Update channel. And so what I'm going to do here is I'm going to promote a new version of my package that has the update to the SQL Update channel. And because I'm on that at-once strategy, they're going to immediately, well, within 60 seconds, they're going to pick that up and things are going to start updating themselves.
All right. Well, I don't sound too intimidated yet. Don't feel too intimidated yet. So let's see the code for this.
No. So let's go ahead and just invoke that promotion right now. So here we have a command that I'm going to launch at the command line. I'm going to promote this new version to my SQL Update channel. So I'm just going to go ahead and run that. So that is now in my SQL Update channel. And really, it depends on timing, anywhere between 0 and 60 seconds. I'm going to expect to see things moving here. So
all right. So while we wait here, so what you did really is the package is already uploaded into Builder and really ready to deploy. And at this point, you switched it into the stable channel, saying, please do deploy this to this particular cluster. So we're just waiting for it to pick up that update.
That's exactly right. And while we're doing that waiting, let's take a look at a couple key things. So the first thing I want to look at over here, this is SQL Server Management Studio. So here I've got my two SQL nodes. I've got SQL 0 at the top and SQL 1 at the bottom. These are the same two nodes that we were looking at in Automate. And I can see here that the one at the bottom, SQL 1, this is my primary node. Here I've got my secondary node at the top. And they're both my Contoso University database. So this is the database. I have an application that's interacting with this database. And these databases are synchronized. And so if we go back to my browser, this is my Contoso University application. So just to show that, like, you know, I have a baseline of things working, let's go ahead and create a new record. So I'm going to create a student.
Always good to be your own student.
Yes, yes, indeed. That works. That's great. Let's go back to automate. So before, both of my nodes were okay, which means that everything was working perfectly. Now both of my nodes are in a warning state. I wrote a health check hook that determines the state of my application. And in this case, let's take a close look here. So SQL 0. This it's basically telling me that this database engine is not yet updated to the version of my habitat package. Now this is totally expected, because when the habitat package updates itself to 3294, my SQL Server engine still has to go through its whole update logic. And I have programmed my habitat run hook in such a way so that when habitat brings down the old version and brings up the new version, SQL Server doesn't get stopped. So what happens is there's a post-run hook where I perform all of this update logic, which is actually happening now as we speak. So right now, SQL 1, which is my, let me just review, SQL 1 was my primary. So SQL 1 is my primary. It's just saying, hey, I'm a little bit behind. Now SQL 0, which was my secondary, it's saying, hey, there's a SQL Server patching in process. So now SQL 0 is critical, which means I can't even talk to SQL 0, which is, again, in this scenario, totally expected. At some point during the update process, SQL Server is going to totally go down and get updated, and it's going to come back up. But that's okay, because I have SQL 1. It's still behind, but it's still serving my traffic and keeping my application up and running. And I'm just going to refresh there. I still see a record, no yellow screen of death. So I know my application is still working. So basically, here's, in a nutshell, here is what the update is doing. When the update kicks in, the secondary node says, hey, I'm secondary. It's okay for me to update myself. And I'm going to go ahead and I'm going to set the failover mode of the primary node to manual, which was normally automatic. Because what we don't want to have happen is, if things were to go wrong with the primary node, we don't want it to fail over to my secondary node while my secondary node is updating itself, because then both nodes would be hosed. So my primary node says, hey, I'm the primary node. I'm not going to do anything until my secondary nodes have all updated themselves. So what my primary node right now is doing is it's watching SQL 0, and it's waiting for its version to be equal to the 3294 version. So if you'll notice, something has just changed. SQL 1 is now in an OK mode, or excuse me, SQL 0 is now back to an OK status, which means it is totally good. It's not even in a warning status, which means that its version is now at the version that it's expected. And now SQL 1 is in the middle of patching. And so what's going to happen is, once SQL 1 is finished with its updating, then everyone will be updated. And so SQL 1 will then fail back to itself. It will then again be the primary node, and it's going to set everybody's failover mode back to automatic from manual. So that means then we'll be in our kind of our normal operating state, where if for some reason somebody were to pull the plug on the primary node, things would just automatically fail over. Here is the health check hook. So this is what a hook looks like. And as you can see, this is just PowerShell. So for those that are familiar with administering Windows and working with PowerShell, this should totally feel at home to you. So all this is doing is it's basically using the PowerShell SQL Server module. It's getting a handle to that instance. It's checking its databases. Can I reach the databases? Are they synchronized? How is my versioning set up? if it gets to the bottom, hey, I exit with 0. So 0 is the okay exit code. All is well. And here we are back in our happy place where both nodes are in their okay state. So both have updated themselves to the new version, and we can go to our application, and we'll go ahead and add just another user, Matt3. You never have enough Mats.
I can attest to that.
Well, so yeah, so all throughout this process, we had nodes coming down, nodes coming back up, but as to our end users who we really care about, it was nobody noticed anything. The system was up. SQL Server high availability did its job. Habitat did its job. And yeah, it all works quite nicely together.
Well, that demo really tied things together for me. I want to thank all of you viewers for joining us for this session, and I want to encourage you to check out some of the other sessions on Habitat this afternoon, including our panel discussion with Panera Bread later on. So if you're excited to hear more about Habitat, definitely check that out. And if you've never tried out the product, I want to encourage you to explore our other resources like Learn Chef, which is a product I work a lot on in order to help you experience Habitat for the first time. Other than that, thank you so much for joining us. Stay safe out there, and we'll see you next time.